Drop your phone right now. Go ahead. Watch it fall. It accelerates toward the floor. Gravity pulled it down. Simple. Wrong. Nothing pulled your phone. Gravity didn't grab it. There was no force reaching up from the earth. No invisible hand tugging it downward. Your phone wasn't pulled at all. It was set free. And when you finally understand what that means, everything you think you know about gravity falls apart. The force you've felt your whole life, the pull keeping your feet on the ground, it doesn't exist. It never did. Let me show you what's actually happening. Stand up. Feel your weight. Feel your feet pressing against the floor. Now ask yourself a simple question. What are you actually feeling? You want to say gravity. Earth pulling you down. That's what everyone says. But pay attention to the sensation. Really pay attention. Where is the feeling? It's in your feet. The floor is pressing up against them. It's in your legs. They're being compressed. It's in your spine. It's holding you up against the floor's push. You feel pushing. Upward pushing. The floor shoving against your feet. Where's the pull? Where is this downward force everyone talks about? Point to where you feel it. You can't, because you don't feel it. You never have. Not once in your entire life have you felt gravity pull you down. You've only ever felt things pushing you up. The floor, your chair, your bed, always pushing, never pulling. Strange, isn't it? The force you've believed in your whole life and you've never actually felt it. You've only felt its opposite. Now here's something even stranger. Imagine you're in a box, no windows. You can't see outside. You feel your normal weight. Your feet press against the floor. You drop something and it falls. Everything feels normal. Question: are you on Earth, or are you in a rocket ship in deep space, accelerating upward? Think about it. If the rocket is accelerating upward at just the right rate, the floor would push against your feet exactly like Earth does. You'd feel weight. Drop something and the floor would rush up to meet it, exactly like falling on Earth. Everything would feel identical. Can you tell the difference? Can any experiment tell the difference? No, nothing can. No measurement, no test, no observation can distinguish between gravity and acceleration. They feel exactly the same because they are exactly the same. This was Einstein's great insight. If you can't tell gravity from acceleration, maybe that's because there's no difference. Maybe gravity isn't a force at all. Maybe what we call gravity is actually something else entirely. Let me explain with a simple picture. Imagine a trampoline, a flat, stretched fabric. Now put a bowling ball in the middle. What happens? The fabric bends. It curves downward around the bowling ball. There's a dip, a depression in the surface. Now roll a marble across the trampoline. Does it go straight? No. It curves toward the bowling ball. It spirals inward. Not because the bowling ball is pulling it, not because there's some invisible rope between them, but because the surface itself is bent. The marble is following the curved surface. It's taking the straightest path it can, but that path curves because the fabric curves. Nobody is pulling the marble. The marble is just rolling straight on a bent surface. And straight on a bent surface looks like a curve. That's gravity. Not a force pulling objects together. A bending of the surface, they move on. But it's not a fabric that's bent. It's space itself. And time. Together, they're called spacetime. And mass bends spacetime the same way the bowling ball bends the trampoline. Earth bends the spacetime around it. Everything near Earth exists in that curved spacetime. And objects naturally follow the curves. Your phone didn't get pulled to the floor. The space-time between your hand and the floor is curved. When you let go, your phone followed that curve. It took the straightest possible path through bent space-time. That path led to the floor. No force, no pull, just geometry, just the shape of space itself. Now let's go back to you standing on the floor. In curved space-time, the natural path points toward Earth's center. Everything wants to follow that path. That's what falling is. Following the natural curve of space-time. But you're not falling. The floor is in your way. The floor is stopping you from following your natural path. The floor is pushing you upward, away from where space-time wants to take you. That's what you feel as weight, not gravity pulling down. The floor pushing up, preventing you from falling, holding you away from your natural path. You're being accelerated. Right now, upward. The floor is accelerating you away from the center of the earth at 9.8 meters per second squared. That's what standing still on earth means. Constant upward acceleration. Sounds backwards, doesn't it? You're standing still, but accelerating. Yes, because in curved space-time, falling is the natural state. Falling is what happens when nothing interferes. Falling is freedom. Standing still is what requires force. Standing still is the unnatural state. The floor has to constantly push you to keep you from falling. That push is real. That push is what you feel. There is no other force. There is no pull. Just the push. Now think about astronauts. They float around in the space station. Weightless. Zero gravity. Right? Wrong. The space station is only about 250 miles above Earth. Gravity there is about 90% as strong as on the ground. The astronauts are absolutely inside Earth's gravitational influence. So why do they float? Because they're falling. The space station is falling toward Earth. The astronauts inside are falling toward Earth. Everything is falling together at the same rate all the time. But they're also moving sideways very fast, about 17,000 miles per hour. So as they fall toward Earth, they also move sideways, and Earth's surface curves away beneath them. They keep falling, but they keep missing the ground. They fall around Earth instead of into it. That's an orbit, constant falling, constant missing, forever. And because everything is falling together, nothing pushes against anything else. No floor pushing up, no force to feel, so they feel weightless. Not because gravity is gone, but because nothing is stopping them from following their natural path through curved space-time. Falling is freedom. Weightlessness is what freedom feels like. Now here's something that really shows gravity isn't a force. Drop a hammer and a feather at the same time. In a vacuum with no air resistance, they hit the ground at exactly the same moment, every single time. The heavy hammer and the light feather fall at exactly the same rate. If gravity were a force, this would be a bizarre coincidence. The hammer has more mass. A force would pull it harder. But it also has more inertia. It resists acceleration more. And somehow these two effects cancel perfectly for every object, every material, every mass. That's not a coincidence. That's a clue. If gravity were a force, different objects should fall at different rates. But they don't. Everything falls together. Everything follows the same path through curved space-time. Regardless of mass, the feather and the hammer don't feel different pulls. They don't feel any pull. They're both following the same curved space-time. And space-time doesn't care how heavy you are. It curves the same for everyone. So everyone follows the same curve. Everyone falls at the same rate. This is why astronauts float. This is why orbits work. This is why gravity affects everything equally. Because gravity isn't doing anything to objects. Objects are just following the shape of space. Now let's take this further. Light has no mass. Zero. If gravity were a force between masses, light should be completely unaffected. It should travel in perfectly straight lines no matter what. But light bends around massive objects. We've measured this. During a solar eclipse, we can see stars that should be hidden behind the sun. Their light bends around the sun and reaches our eyes. The sun's mass curves space-time, and light follows that curve. Light isn't pulled by gravity. Light doesn't have mass to pull. Light follows the curved space-time that mass creates, and that curve bends light's path. This is called gravitational lensing. We see it all the time. Giant galaxies bend light from objects behind them. The bent light creates distorted images, sometimes multiple images of the same distant object. Space-time acts like a lens because space-time is curved. Newton couldn't explain this. In Newton's theory, gravity is a force between masses. No mass, no force. Light should go straight. But Einstein predicted exactly how much light would bend. And when scientists measured it, Einstein was right. Perfectly right. That was the moment everything changed. That was the proof that gravity is geometry, not force. Now let's think about something even more extreme. What happens when you curve space-time a lot? When you have enormous mass in a small space? The curves get steeper. The paths get more bent. At some point, the curves become so steep that every possible path leads inward. There's no way out. Not even a path for light. Light tries to travel straight, but straight leads inward. Every direction leads inward. That's a black hole. A black hole isn't a cosmic vacuum cleaner sucking things in. A black hole is a region where space-time is so curved that all paths lead to the center. Nothing escapes because there's no path that leads out. Geometry itself traps everything. Light doesn't get pulled into a black hole. Light follows space-time, and near a black hole, space-time only curves inward. So light goes inward and never comes out, all from the same idea. Mass curves space-time. Objects follow the curves. So what is gravity really? Gravity is not a force. Gravity is the shape of space-time. Mass bends space-time, and everything moves through that bent space-time, following the straightest paths they can. What you feel as weight is not being pulled down, it's being pushed up. The ground is accelerating you, preventing you from falling, holding you away from your natural path through the universe. When you drop something, you're not watching gravity pull it. You're watching it finally move freely, following the curved space-time it was always trying to follow. When the moon orbits Earth, it's not being pulled in a circle. It's falling straight through curved space-time. And that straight path happens to loop around. Gravity is geometry, nothing more. And here's the strangest part. You're sitting still right now, or standing, or lying down. You feel stationary, but you're accelerating. The surface beneath you is pushing you, accelerating you upward through curved space-time. You're experiencing constant force, constant acceleration, every moment of every day. Falling is the natural state. Stillness is the forced state. Everything you thought about gravity is backwards. The pull is a push. The force is geometry. Falling is freedom. That's what gravity actually is. Not what you expected. Not what anyone expected. But that's what the universe does. It takes your simple ideas and shows you something stranger, something deeper, something more beautiful than you imagined. Gravity doesn't pull. Space curves, and everything just follows. That's the misconception everyone has. We feel the floor push us, and we call it gravity pulling us. We watch things fall, and we imagine an invisible hand yanking them down. We picture forces and pulls and attractions, but there's nothing there. No force, no pull, just curved space and objects following the curves. The next time you drop something, watch it carefully. You're not watching gravity work, you're watching geometry. You're watching an object finally free to follow the shape of the universe. And the next time you feel your weight, remember what you're actually feeling. The ground refusing to let you fall. The floor pushing up against curved space-time. The constant acceleration that keeps you from freedom. That's gravity. Not a pull, a shape, not a force, a geometry. And that changes everything.